Build AI security around your system and send in the secure AI agents to kick out the fraudsters and fix technical debt.
Today, I'm going to demonstrate how our solution can prevent against data leakage, things like PII and PCI DSS, sensitive information. We are also able to detect hallucination. I would like to see it as a reliability check and detection, and I'll demonstrate that. And lastly, I'm going to also try to use our fraud detection system to detect any fraudulent suspicious transactions. In this case, we're going to be simulating fraudulent data into a transaction that we'll be sending over. Just this test application, it would essentially be any application. It could be the bank's system, or it could be any other software that is needing our solution that can be integrated easily with API. So here I'm going to just upload a file that contains some data that has PII and sensitive keywords in there. So I'm going to just try to say import transactions. And then this, as you can see, is basically scanning for sensitive key words like phone numbers, SSN. It's interacting with Zero Trust AI's API, and it's actually doing all accept it or anonymize it. So in this case, we have a few phone numbers, social security names, this data, as you can see here, and we would choose the option to send it over to the L1. Reliability and hallucination. And we're going to have the option to do that here. And we're going to run this, and it's basically scanning. Came back 99%. It says the response is highly relevant, detailed, and reliable. It thoroughly analyzes, so it looks pretty good. So one of the tests I want to do to see if we can get the data to fail is I can ask a question like, what's the current US tax rate, for example? It's not, doesn't have access to the internet, so it wouldn't know that, and so the results wouldn't make sense. Hence why we cannot take that data. So it's basically telling us it can't get that information. So now, if we want the reliability to fail, basically because we're just evaluating this response as if whether or not it answers our questions correctly, and we know it didn't. So it should give a poor result. So there you have it. So it gave it 10% because the response does not answer the prompt about the current US tax rate. So that's how we essentially would know it's actually not answering the right question. We're hitting Zero Trust AI's endpoints. So I would go to the dashboard where we can easily see the latest snapshot of the data. So here we would go under the API usage. And if I click over here, it's going to load. And I can show you here is where it says, what's the current US tax rate? And it called the endpoint evaluate reliability. The last one we did before that was when we so we did 2 reliability checks. And then we also did anonymize sensitive keywords. And let me go into the actual log so we can demo. So like I mentioned, here's the reliability check 2 of done that I did. And here's the data comparisons that I took. And let's look at the sensitive keyword, the anonymization. Here's the whole data, and that's the response that you get. And then lastly, here we can see how we detected the sensitive keywords. So anyways, this is this is how Zero Trust AI provides the ability to protect those sensitive data, and also do the anonymization, and also do the hallucination reliability detection. Next, I would like to show the fraudulent transaction protection. So here I'm going to generate seed data, and essentially that's just going to comprise of different kind of records. Is going to contain some fraudulent transactions. In this case, we put 9 in there, even though the entire transactions would have a lot more records. So we basically injected some fraudulent transactions there. So if we go to the fraud validation, so this is still the app that we're using to test. So it really it's just essentially data that we've just put some good and bad ones in there, right? And now we are going to send some of this over through by calling API of Zero Trusted AI to see if we can detect which of this information is actually, and all we just sent is raw information. We just put limited information, the transaction and the description, and that's it. And so from Zero Trusted AI's platform or the connection, this is the bank connection. We're going to re-add one. So now let's add a connection to our app. Change the URL. Schedule here, which is supposed to run monthly, but in this case, we do not care. We just want to run it instantly. So the scan has been initiated, and it's going to start fetching batches of data from the bank and by calling the API. And as it's going to evaluate each of these transactions until it finds the fraudulent one. And we can see the payload that it's sending over to Zero Trusted AI. It does not contain any information about whether or not it's a fraudulent transaction or not. It just puts general information, transaction information. So given this information, Zero Trusted AI is going to try to figure out. So here is flagged 5, is process 50. So it seems there were 72 transactions in general. So we need to go, so it's 72 transactions. So here we are going to do a refresh to see the results. So we can filter and say detected. So it detected all 9 transactions. It detected them. And there is a feature here to see why, the actual reason that this actually, by the way, the ground truth is the bank that the simulated data generated that. So, and it can explain the reasons here. And the reason the scanner gave is this. So it's similar. So this is fraudulent because it's from Panama and is unusual. And here it's just basically saying 5 times typical the max. So it used a different parameter to detect it, but it detected it nonetheless. All right, so there you have it. So it's 100% detection rate, precision, and when I do missed, there's none missed. Clean, those are just transactions that they were regular transaction. And if you notice, it also didn't get any false detections. So this is pretty good. One thing I left out is when we go back to the Zero Trusted AI, we can actually see details. So 22 or 2050, we can see each of the transactions and the detection it gave. So it's explaining the deviation. This is the analysis that's given back on each transaction, and it gives it a risk score. So it only found 4 it flagged there. So here it flagged 5, and these are the 5. There's also a feature for reinforcement learning, which also is kicked in periodically. Should there be newer transactions is unable to detect, it will be used, that miss would be used to retrain it.